Hi, in this video I'm going to show you how to make a stem and leaf plot, and we're also going to learn how to describe data. So first let's go ahead and take a look at the data. That the question is how many shoes. So 20 females were surveyed and were asked how many pairs of shoes do you own, and these are the responses. So first, before we start, stem and leaf plots are useful when we have small data, and we can construct this by hand. So the first thing I'm going to do is I'm going to take the data that I have and I'm going to list it from least to greatest. So I'm going to take a look at all the numbers and I'm going to rewrite them from least to greatest. So you can circle them. So I can see I have 13 here. And I have another 13, and I have a 15. And are there any teens? There's a teen, 13, and 15, and 19. All right, then I'm going to continue. All right, so that was a bit tedious, but the first thing you want to do is, and we forgot a number, 57. So 57 I will place right here. Okay, so the first thing I'm going to do to create a stem and leaf is I'm going to draw a bar, like a vertical line. And of course, I'm going to write a title for this graph. So I will just call it How Many Shoes? So anytime you are creating any type of graph, you must always put a title so you know what we are looking at. All right, so what we're going to do is we're going to list the numbers from least to greatest, and this over here on the left will be my stem, and the leaves will go on the right side. The stem will be on the left and the leaves will be on the right. So because I have numbers that are listed in from 13 to 73, I'm going to create a key. So what does a key mean? It tells the person that's looking at the graph how to read the numbers. So for example, you can choose any number from your data or not even from your data to make a key. So I'm going to write key here, and I'm going to say, for example, 4-9 is equivalent to 49. So that when someone is looking at your stem, they know what the numbers represent. All right, so I have numbers from 13 to 73. So I'm going to number 1, 2, 3, 4, 5, 6, 7. So I'm going to include all my data here. The stem will include the first digit, and the leaf will include the last digit. Now, that's just how my key is. So let's say my data had decimals like 4.1, 4.3, then I would need to show that on my key that 4-9 could represent 4.9. Let's say my data had numbers in the hundreds, so I would need to show my key as maybe 10-0, 10-0 or /0 represents 100. So only the last digit goes in your leaf. All right, so now comes the fun part. We have listed the numbers from least to greatest. So these are all my numbers that are in the tens. So I'm going to go ahead and add 13, 13, a 5, and a 9. So that when I read this from left to right, this represents 13, then I have another 13, then I have a 15, and I have a 19. So it organizes my data. Then we're going to go on to the 20s. We have a 22, we have a 23, a 23, a 24, a 26, and another 26. So that covers all my 20s. Then I'm going to continue to the 30s. I have a 30, I have 31, 34, and 38. Let's see how many in the 40s. We just have one, so 49. Then we have 50, 51, and 57. And then we have 73. Okay, now here's the thing. Be careful. Never skip a number that is in between your data. So what do I mean by that? I don't have anything in my data in the 60s. So be sure not to skip the number 6, and also be sure not to put a 0 here, because if I would put a 0, that would represent 60. But I do not have any numbers in the 60s. So this shows me an empty space or a gap. Now, the nice thing about stem and leaf plots is that you can see the data. You know exactly what your numbers are. You can look at them, and you can also look at the shape. How would I look at the shape? Well, if I flip this horizontally like this, it almost looks like a dot plot. You could see that most of the data is on the left, and then there's some on the right. So later on, we're going to look at shape, and we're going to pretty much describe this as skewed to the right, because I have most of my data up here. If I drew a little imaginary curve, most of my data is here, and my tail goes to the right. But that's something we're going to discuss later on. So this is pretty much it for constructing a stem and leaf plot. All right, so now let's say we wanted to compare two sets of data. What happens? So these are how many shoes for females, by the way. So females were asked, and this is how many pairs of shoes they own. And yes, you may say, wow, 73, that seems like an outlier. So you never want to state something is an outlier unless you actually use the IQR rule, which is something we're going to discuss later on. Now let's do the same thing if we have to compare it to, we asked the same questions for males. And we said, how many pairs of shoes do you have? And this is their data. So how would we create a back-to-back stem plot comparing the two? Well, I could create a stem plot for the males, just like what we did. And if you can see, we have numbers that are less than 10, 7, 6, 5. So how would you do that? Well, you can easily write down 0, 1, 2, 3, 4, 5, 6, 7. So I'm going to recreate, and I'm going to do a back-to-back stem plot. Now I could easily create just a stem plot for the males, but you already know how to do that. If I want to compare two stem plots, then we are also going to write a title for this. And in the middle right here, this is going to be my stem. So this is the stem right here. And I'm going to put female, how many shoes? I mean, we could title this really, how many pairs of shoes do female have? Or we can just put male here. So we know this side is the male and this side is the female, and we're talking about how many shoes they have. So if I just copy directly the female data, I have it here. So I'm going to go towards the right. Now, I could have put the female on the left and the male on the right. It doesn't really matter. As long as you write down which one is which is why we have a title. So this is the female. Let me make this nicer. This is the female on the right. I'm going to just rewrite it. You kind of want to space it out so each number goes vertically below the other. For an 8, then we have a 49, a 50, 1, and a 7, and a 73. Okay, we're going to write a key again. We could use the same key. We could say 4/9 equals 49. You can also say 0/7 equals the number 7. So you know if there's a 0 in the front, that means 7, which is the case here. All right, so I'm going to now create the male stem and leaf. Now, if you notice, these here are the leaves. So anything to the right or left of the stem are the leaves. Now to the left, I'm going to go ahead and hopefully I won't leave anything out. but I'm going to see any number under 10 and I'm going to write it to the left. So right now I'm going to circle a 5, a 6, a 4, all my numbers that are under 10, and I'm going to list them in order from least to greatest. So I think I covered all of them. Oh, there's one more here. Okay, so which is the smallest one? It looks like 4. So this is 4. So notice, be careful here. This is the mistake students make. They read this as 40. This is not 40 because if you look at this, it says 0/7 represents 7. Now, why is this not 40? Because we read with the stem first and then the leaves branch out. So we're going from the stem first and out. So this represents 4. 4, 5. I'm going to cross these out as I go along. And then I have another 5 and another 5. So 3 5s. I think I have 3 5s here. Yes, 3 5s. And then 1, 2, 3 7s. So 1, 2, 3. I think there's 4 7s, one more 7 here. So that is kind of long. All right, so I'm going to talk about what happens when you have a long set of data that goes like into a huge tower. What we normally do then is we split the cells. What does it mean, split the cells? We will have 2 0s and 2 1s and 2 2s and 3 3s. So that way we have 5 in each column and no more. So we would kind of stop at 1, 2, 3, 4, 5. And then we would take the other 3 and start a new one. All right, but I'll leave this for now. Okay, so in the teens, we have 1, 2, 3, 4, 10. So I will write 1, 2, 3, 4. Now again, this represents the number 10. This means there's a number, another 10, another 10, and another 10. So 4 10s total. Okay, and then let's cross those 4 out so we don't repeat anything. Then we have an 11, so I'll put a 1 here. And then we have a 12. And then we have a 14. And I believe that covers all the 10s. Okay, then we have a 22. So that will be right here. A 38. Oops, I skipped a 5. So first I'll put the 5. You always want to put least to greatest. So 35 and then 38. And I think we have covered everything here. Yes. All right, so now that it's back to back, we can compare the data. So if I flip this over horizontally, I could see that my data is going, a lot of it is on the heavier here on the left and skewed to the right. When I look at the male, I could see, and be careful here because now I'm reading 0 is on the right, and usually 0 is the smaller number, so it goes on the left. So be careful when you're switching to see what it looks like, but you can easily compare a back-to-back stem plot by looking to see, for example, if I said who had the most pairs of shoes. So then you would obviously say, okay, one of the females had the most pairs of shoes. Who had the least pairs of shoes? So one of the males had the least pairs of shoes, and that would be 4 pairs. This would be 73 pairs. Where would be your center? Where would be your median? These are all questions you can get from looking at a back-to-back stem plot. Okay, and this basically concludes how to create them by hand.